So I'm going to introduce natural logarithms and explain base e to you. So these are what are exponential functions in natural logarithms for base e. I've got 20 previous videos that are linked in this description if you need them. And if you become lost or confused, it could be really helpful. So one of the most important numbers in a rational number called e occurs in advanced math, economics, statistics, probability, and in many situations involving growth or decay. And e is approximately this nice long decimal, the exponential function base e, as e to the x power, and its inverse, the logarithm function base e, as e to the inverse of x. See the little negative sign there? They're important in math theory and applications. So this is just like pi, where it continues on forever and ever and ever. So what we do is we just use 2.7. Logarithms to the base e are called natural logarithms, and e is approximately 2.7, just like we would say pi is approximately 3.14. Well, this is approximately 2.7. And we remember if we have a zero exponent, then it's going to make that number equal a 1, isn't it? And if we have an exponent of a 1, e to the first power, well, that's just 2.7. All right? So e is a fundamental number in our universe, and because of this, e, just like pi, is called a universal constant. The letter E is used to honor Leonard Euler, who published many results for E in 1748. So that's what happens when you don't have television or a cell phone. You sit around doing math in 1748. So just like pi, E is an irrational number. Its decimal expansion never terminates or repeats. And logarithms to base e are called natural logarithms because they occur naturally in nature and sciences, like biology and stuff like that, and social sciences like politics and economics. The base e logarithm of x is written, this is a lowercase l and an n, not an I, so it's a lowercase l and an n, and then the letter x, and it's pronounced lnx. Log base e of x, we ask ourselves what exponent of e will equal x, just like we have so far all along with the logarithms, right? If you see y equals log base e of 7.34, we need to know what exponent of e will equal 7.34. And it's approximately e to the second power. Well, you can use a calculator or log table for function values, e to the x and e to the inverse of x, to solve these. That's what we're doing in the next video. So remember, a logarithm is an exponent, all right? When we take a number with a decimal value that never ends, like e or pi, and raise it to a power, the decimal value gets difficult to handle effectively. They get awkward. And we usually leave our answers as multiples of e instead of switching to decimals. You would never do this. It's this long decimal that is going on and on and on forever with the ellipses and putting an exponent there. You just do e to the x power, all right? So e is used to find continuously compounded interest, radioactive decay, population growth, and other applications which involve growth or decay. So, as I mentioned here, our next video is 12.8b, and we're going to find natural logarithms with a calculator or a table. And I even did a little short video, 10.3d, about e, and those 20 videos for this chapter 12 are going to be linked in the description. I'll add this to the Algebra II playlist, and I hope you now understand about e. So now we can solve them. Now you know what they are. Now we can actually work with them. Okay? I'll see you next video. Bye.